Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem. That is the remove nth node from the end of list. This is a middle type problem, and we'll understand various approaches we can do, and ultimately we'll write an approach that will be the faster in terms of like understanding and the concept as well. Okay, because like all the approaches we will discuss will end up somewhere around 0 ms solution, like all are fastest. So we'll just ultimately write something which is comfortably easier or a better solution in terms of an interview. Okay, so that's more or less about this video. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question says we are given the head of a linked list. Fine, the head given. We need to remove the nth node from the end of the list, okay, and return its head. Fine. So what it means, say when n is 2 and this is the linked list, like this is the linked list given to us, and our n is 2. So in that case, what exactly we are doing? We are doing like second node from the end, right? So this is 1, this is 2 from the end, okay, and we removed 4, and ultimately you see like after 3 there's 5. That's how we just linked it. So when you want to link it, what we are actually trying to do with that, this particular node dot next is equal to this particular dot node dot next dot next. So we're just linking this to this. We're just ignoring the address of this. So that's how linked it works, linked list works. Fine. So how we should do this? Like I think the concept is clear, like what we should do, but the next thing is how we should do this. The first thing you can do is this is not the best case, but let's understand this first. We are given how many nodes. We are not sure how many nodes are given to us, right? So what we can do, we can actually go ahead and count them. We can run a while loop, okay, and keep counting how many nodes are there. Like it's a 1, 2, then 3, then 4, fine, then 5. Like how many nodes are there? We found that there are like 5 nodes are there. Then what we need to do? We need to traverse till in like this one, like 5 minus 2, 5 minus 10, traverse till this one, and then mark this dot next equal to this dot next dot next. That's what you need to do. Fine. So this is the kind of approach you can go ahead with. But there are two things you are doing. First time, you are counting the number of nodes you have for, in our list. Like, so in that case, what's happening? You are traversing the whole list. I mean, one traversal is happening for the whole list. But can we minimize this? Like, if you see clearly, we are traversing the list 2 times. Okay, once we are traversing to count the number of nodes. Next, we are traversing to do our exact operation. Now the question is, can we minimize this? I mean, obviously, the in both the like in this cases, it remains as order of n because you are traversing through the n number of nodes in single run. It remains order of n, but we need to see whether we can like minimize the like number of traversals. Okay, so in that case, what we can do is like say we will go ahead with 2 pointers basically. Now, what our approach will be, say we first mark say we first mark another pointer that is say slow and fast. Okay, so we took 2 pointers and all are pointing to something before this. Fine. Now what we'll do, we first take this faster pointer, and we will traverse this in a manner like it will go how many steps? It will go n number of steps. Fine. Actually n plus 1 number of steps. So what will happen? N being 2 will move it to 3. So if first travels over here, then over here, and then over here. So n travel like our fast pointer travels like it travels to this position. Now if you look carefully, slow is standing like before this one. Fine. And our f is fast solution is standing at 3. So the difference between them is more or less like 2 units, right? Exactly that n unit difference remains between them. Now keep traversing this f once and then slow keep traversing this slow once. Fine. Whenever we reach fast, you will see our slow has reached this 3. Fine. Because like that's how we are going through it. Fine. So in that case, what is happening, like we are always maintaining the distance of like what's happening is slow is over 1, then like I just drew something bad. Yeah, so slow like fast moves to 5, but slow moves to 2, fine. Then fast moves to a null value, fine, after that, and now slow moves to this 3. We are now know that the difference between them is exactly 2 units, right? Now what we need to do, we need to just traverse slow dot next equal to slow dot next dot next. We are just marking this to that. Now what's happening exactly, we are traversing it twice, but only in a single run. Like we are not traversing in a two different runs, like it's traversing, the order of n traversal is going on, but that too in a single run, because both the pointers are traversing all at once, like, or both are traversing at once, right? So what happened, we just made a fast pointer to mark the difference between the nodes, like slow and fast pointer as something like this, like number of n being the number of node difference we need. So we just mark this difference and we keep this difference maintaining, and ultimately whenever we ended our whenever this fast solution ended in a null, then we know our slow pointer needs to be marked as slow dot next equal to slow dot next dot next. We're just skipping this position. So that's how we are traversing through it. Okay, so this is a much better approach. Like in an interview, like many times they ask this. So in an interview, if they ask you this question and you come up with a solution that where you are first calculating the length of the linked list and then you are traversing it, so that's not the best case. They will ask you to improve it. Fine. So this is the kind of improvement you can come up to. Okay, you just took 2 pointers and then move one and maintain the distance and then keep traversing based on that. So we'll use this like this slow fast pointer one. Fine. So in this case, one thing you need to remember is like the both the cases we discussed is like both are having an order of n complexity. Fine. So the order of the time complexity is not changing anyway. Fine. So let's go ahead and write this code. Fine. Let's write this code and see how this works for us actually. And as I said, there you say this like 0 millisecond solution as well. Fine. Let's quickly understand how we'll solve this in our code. So in our code, what we did, we first took a new head. Okay, a new head. This is a new link list, or you can say a new node we created with value 0. So this is just a temporary variable. We're just creating a new head in the sense something before this, like there's one and we're creating something before this, and then we're making it new head dot next equal to head. So we're just marking it new head dot next equal to next. Okay, or like head. So we're just marking it like that way. Why we're doing so? Because we are not sure whether this would be the one that is going to be deleted or which one is the one that is going to be deleted, right? So if a head is the one that is going to be deleted, so we're not sure about that. So it's better we just start something before that and then we see which one is the exact question that's need to be deleted. Fine. Now we took two more pointers like slow and fast, as I said, both are pointing to this new node. Fine. The before this. Now while n minus minus greater than 0, we are moving fast. So till the like number of distance we need to maintain, we're just moving fast, one by one by one. We're just doing this. Right. Further, we what we're doing. This is the rest of the traversal. Rest of the traversal is like while fast dot next not equal null. Like while fast dot next, we're just looking for this position. While fast reaches this position. So fast is fast dot next and slow is slow. We're traversing both over this time. Fine. Now after this traversal is done, that means fast reached something over here, and then slow is reaching something over here. Now we're doing slow dot next. Okay, that this pointer we are just pointing this back to this. Okay, so we're doing slow dot next equal to slow dot next dot next. Fine, and thus we finally return new head dot next. Remember this. Don't return head directly. Fine. There's a reason why I'm telling this. If you are returning head directly and say here is a like in this particular example, let's say here say like this one is 5 itself. Okay, if this one is 5 itself, and then what will happen, we need to delete the first node, right? We need to delete the first node. Now if we return head is pointing to this first node. Fine, you have not changed the point of this head anyway. Fine. So you need to make sure that you got this new head, and you need to make sure whatever is its next, either this one or by any chance it moved to this one, you need to like return that position. Fine. So that's why in necessary you just return new head.mix, not head directly. Fine. So this is about the whole question, guys. As you saw, like this is kind of an 100 millisecond, like 0 millisecond solution as it is. So I hope it is understandable. And if you still have any doubts on this, make sure to comment them down in the comments as well. I'll be happy to help you out in the comments as well. Also, like this video and subscribe to this channel for regular LeetCode videos like this. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.